Next, in our discussions on linear algebra, I want to talk about basic mathematical operations using matrices. So matrix addition is fairly straightforward. It occurs element by element, same with subtraction. So there are two rules. The matrices must be the same size, and remember the size is given by the number of rows by the number of columns. And the resulting matrix is going to be the same size as the two matrices added together. So the general form here is the matrix C equals A plus B. Notating element by element, it's Cij equals Aij plus Bij, or minus if you're doing subtraction. So here's an example. If I have matrix A that's a 2 by 2 and matrix B that's a 2 by 2, I can add them together and the resulting matrix would be a 2 by 2. So here we have C11, C12, C21, and C22. So let's work through these one step at a time. If I want C11, I would add A11 and B11. So it's element by element. We take each 1 element and add them together to get the C11 element. So if I add 2 and -4, I get -2. For C12, I would add 3 and 3 to get 6. For C21, I would add 8 and 3. Again, it's both the 2, 1 elements, and I would get 11. And lastly, you would add the 2, 2 elements and get C22 to be -6. So the final sum is -2, 6, 11, and -6. Next is scalar multiplication. So a scalar is just a constant value, and so the only rule here is that the resulting matrix is going to be the same size as the original matrix. So if we say that D is equal to the scalar K times the matrix A, the general form written out is Dij equals K, which is the scalar, times Aij, which is the element in the matrix A. So another example here, let's look at the matrix A and a scalar K equal to 3. So if we write this out, we have a 2 by 2, which is equal to 3 times our 2 by 2 matrix A here. And again, these all occur element by element, so we take the to get D11, we take the A11 element and we multiply it by our scalar. So we have 3 times 2, which is 6. For D12, it's the scalar times A12, which is going to be 9. And then D21 is 3 times A21, which is going to be 24. And lastly, we have D22 is equal to 3 times A22, and that will give you -6. So the scalar multiplication of K and A would give you 6, 9, 24, and -6. Derivatives and integrals are also element by element, so all you have to do is take the derivative or integrate each element individually. So if we wanted to find the derivative of x with respect to time t, and x was given as a 3 by 1, we'll call this v, or maybe the velocity, since we're taking a derivative of a x matrix with a vector with respect to time. So we would just take the derivative of each of these individually. So the derivative of the v1 term would give you -8 sine of 2t. The derivative of the x2 term would give you 2t minus 3. And lastly, the derivative with respect to t of the x3 term would give you -e to the -t. So you put them all together, you get your vector v. Matrix division, it's pretty simple. It does not exist. So moving on. The transpose is useful in doing linear algebra. So the rules for the transpose are you're going to interchange the rows and the columns of the matrix. So if A is a 3 by 4, then the transpose of A, which is designated with a superscript T, would end up being a 4 by 3. So the general form here is B is equal to A transpose. So Bij would be equal to the element Aj. So if we want to find the transpose of A, which is a 3 by 2, we take the first column and we make it the first row for A transpose. And similarly, we would take the second column and make it the second row for A transpose. And then just to finish up here, a couple useful identities of the transpose. If you take the transpose of a transpose, you end up with the original matrix. If you take the transpose of matrix addition, it's the same as taking the matrix addition of each of these transposed. The one that gets used a lot is number 3 here. If you take the transpose of matrix multiplication of A and B, it's actually B transpose times A transpose. And then lastly, the determinant of a transpose matrix would be the same as the determinant of the original matrix.